Hello, everyone. This is Keith Jackson, and welcome to Jack's Math Notebook. Today, we're going to continue our study of compound inequalities, but today we're going to study the OR compound inequality, which means the combining of regions known as union. And before we get started with our big example one, let us do a trial run right here, what a compound inequality will look like when you graph it. And so in this case, we have x is less than 3 or x is greater than 7. First, let's take a look at x is less than 3. Because x is less than 3, we're going to put an open circle over the 3. And since x is less than 3, we know that x is to the left of 3, indicating that x is smaller than 3. And at the same time, x cannot be 3, as indicated by the open circle. On the other hand, we have x is greater than 7. We're going to put an open circle above the 7, and then we're going to write the arrow, draw the arrow to the right of 7. And so in this case, it's letting us know that 7 is greater than, or I should say, yes, x is greater than 7, but x cannot be 7 itself. Okay, and let's take a look at this case in which we have x is less than or equal to 3, or x is greater than or equal to 7. Notice that the points right here and here look identical to the first drawing that we see here, but the difference is that because we have a less than or equal to sign, we have to have a shaded circle above the 3, and still x is to the left of 3. But in this case, it's also showing that x could be 3 itself, and so x could be 3 or less than 3 in this situation. That is why the arrow is being drawn to the left. Now let's take a look at x is greater than or equal to 7. And in this case, we have to draw a shaded circle over the 7 while the arrow is being drawn to the right. And that lets us know that x can be 7, but it can also be greater than 7. Let's go to our big example to further our understanding of this concept, in which we have, in this case, x plus 2 is less than negative 6, or x plus 2 is greater than 6. All right, we're going to do our regular algebra here because we're going to isolate x on one side of the inequality. As you see right here, we're going to do that by subtracting 2 from both sides of this inequality. And when we do that, we get 0 here and we get a negative 8 here. And this shows us that x is less than negative 8, knowing that we have to put an open circle above the negative 8 and drawing the arrow going to the left of negative 8, indicating that x has to be less than negative 8. Now let's go over here to this side in which we have x plus 2 is greater than 6. Again, subtracting 2 from both sides of this inequality, showing us that x is greater than 4. And so we're going to draw an open circle above the 4, drawing the arrow headed for the right of 4, knowing that x can be greater than 4, but it cannot be 4, as indicated by the open circle. And so right here, notice that they look identical almost to the one up top, but because in this case, we have a less than or greater than symbol here, and we have a greater than or equal symbol here, or I should say we have a less than or equal symbol here on this side, and a greater than or equal symbol on this side, we have to make sure that our circles are shaded. And we could just pretty much perform the same operation in which we have x plus 2 is less than or equal to a negative 6, subtracting 2 from both sides to isolate the variable x. And when we do that, we have x is less than or equal to a negative 8, putting the shaded circle above the negative 8, drawing the arrow going in the direction to the left of negative 8. But in this case, x can be negative 8, but it also can be less than negative 8. And let's go on to the other side in which we have x plus 2 is greater than or equal to 6, subtracting 2 from both sides to isolate the variable x. And we have x is greater than or equal to 4, putting a shaded circle above the 4, drawing the arrow going to the right of 4. And in this case, x can be 4 or it can be greater than 4. All right, you have been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at what this anchor chart has to offer. or replay this video as many times you need to gain a deeper understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.